All right, so multiplying and dividing rational expressions is really a continuation of what we did yesterday in simplifying, because multiplying and dividing really leads to a simplification with just an additional step thrown in there. So steps to multiplying. So steps for multiplying. So first step, number one, factor all numerators and denominators completely. Which amazingly is the same as step one from yesterday, right? Factor all numerators. There'll just be more of them because we're multiplying, we're going to have more expressions. So we're going to factor everything completely. Number two, state the restrictions. So far, step two is exactly the same, right? So step one, factor everything. Step two, state the restrictions. Okay, and where do these come from? It's from the denominators, right? Now this is in multiplying. There's going to be a little extra in dividing. But we'll wait till we get there. Step three, divide out the common factors. Between a numerator and a denominator, right? Anything on the top cancels with the same thing on the bottom, right? But it has to be top to bottom. So divide out the common factors between numerator and denominator. And I'm trying to do an ampersand. And denominator. These three steps look familiar? Exact same three steps from yesterday, right? Factor everything, state restrictions from the denominators only, divide out the common factors, and express your answer. So now here we get a little different. So express your answer as a single rational expression. Okay, and we'll go with RE for rational expression. So express your answer as a single rational expression. So them's the four steps, right? All right, so what did we do when we divided fractions? What did we have to do first? So we changed it from division to what operation? Multiplication, and what did we do with the kiss and flip, right? Okay, so we are going to take the reciprocal, we're going to multiply by the reciprocal of the divisor. So we're going to change division to multiplication by multiplying by the reciprocal, which just means you're flipping it, right? It's all reciprocal. By the reciprocal of the divisor, the thing you're dividing by. Now follow the steps for multiplying. Okay, so we just had that one additional step, right? It's nothing that we're not familiar with. We've done it with fractions. You know, a half divided by a quarter becomes a half times 4 over 1, and away we go. And that's all we're doing here. So if we see division, we just say, okay, I'm going to rewrite this as a multiply, and then I'm going to do the four steps for multiplying. I'm going to factor everything. I'm going to state my non-permissible values. There will be one additional thing with non-permissible values and division, so we just have to be aware of that. And then we're going to cancel common factors. Okay, so let's do some. So to start with, we're just going to start off with an easy one, right? We're just going to state all restrictions. Okay, so that's it. We don't have to simplify anything, right? Well, maybe we do in order to get a restriction. Oh, wait. Green box day. So what we need to do is state all restrictions. Okay, so here we go. We've got 2x over x plus 4 times, so the little dot means times, right? It could be a little dot, it could be an x. They could be written in brackets next to each other. All of those mean to multiply. See, it gets more full. The later you get, the closer you have to sit. 2x over x plus 4 times 3x times x minus 4 over 5x minus 1. Okay, all I want is restrictions. What are the restrictions on this? X cannot equal? Sorry? Negative 4. Anything else? Speak loud, hold ears. Positive 1/5. What else? What else? Come on. Huh? Can it equal 0? Yeah? Good. I was just trying to badger you into an answer that, you know. There are no else. There's nothing else. Yeah, see? Gotcha. Yeah. Don't get rattled in math. It's not a good thing. You don't want to get rattled on a test, right? I mean, that's a bad thing. So we don't care, right? This can be 0. That's fine. This can be 0. That's fine. It will lead to a 0 up top, but you put a 0, you get a 4. You put a 0, you get a negative 1. So it's fine with 0, okay? There are no others, right? Good. But now game's going to change a little. So 2x squared over 5 divided by x cubed over 3x plus 1. Okay, what's the first step in division? Multiply by the reciprocal, right? So we're going to change this from a division to a multiplication. So it's times what? Three x plus 1 over x cubed. Okay, now to do restrictions, we have to look in denominators, right? How many denominators are there? 2. What about this? Because that's really a denominator, isn't it? In the original expression, this is a denominator. So if this thing somehow evaluated to 0, this thing would be undefined, and you'd be trying to divide by undefined, which is kind of tough to do, right? So in a division, there are 3 denominators. There's 2 original denominators, and then this guy, which becomes a denominator because of the kiss and flip. Okay, so you need to, for non-permissible values or restrictions, look in 3 places, right? The only place you don't look is here. The upper left was always on the top, so it didn't matter, right? You think about it, because if this x is 0, that's going to turn this expression into 0. And then you're trying to divide by 0, right? So this whole thing is really a divisor, okay? So just keep in mind, when I divide, I've got my 2 denominators here, but then I've got a 3rd denominator here. So what are my non-permissible values? Let's start here. What's this one? Negative 1/3. What's this one? There's 1. What's this one? 0. Okay. So in division, so that's really, this is it, right? Today's lesson could have been when you divide, you multiply by this, and now you've got 3 places you have to look for non-permissible values. Otherwise, you know how to do this, go ahead, okay? But I'm not going to, you know, we'll do a bunch of examples, because you guys like examples, and that's okay. All right, so let's do some. Simplify. What is this? We'll call this number 2, simplify, simplify, right? Which is really all the instructions you get. That's all it's going to say is simplify, right? Simplify means turn it into a simpler form, right? Not come up with a value. You can't evaluate it. Evaluate means give me a value for it. Solve means find the value of. Solve and evaluate are really pretty much the same thing, right? Simplify. I just say this because a lot of times people want to solve things that can't be solved. It can only be simplified. So simplify, I'm going to just add a proviso. We're going to use binomial numerators here. Binomial numerators. Okay, and remember restrictions, right? So whether we say it or not, you always need to. If we don't ask for them, we probably won't mark it. All right, but you have to be aware of it. This comes in a few days down the road. You need to be aware of restrictions because when you do get to the point where you're solving, sometimes you solve and get a value that you can't use. You get a non-permissible value, and you have to be able to say, hey, that's not a solution, right? It became one because of stuff we did, but it never was one. Okay, so remember restrictions. Okay, so if you always state the restrictions, then you never have to worry about, you know, do I do it in this case or not? Yeah, okay, we're always going to do it. Okay, now obviously if it's a multiple choice question, you can't state restrictions unless it's just asking you what the restrictions are. But, you know, otherwise if it's written, just state the restrictions. Okay, a 15x over 25x squared times 2x. Now, how do you want to do this? And I'm actually open to suggestions here, right? Because different people may want to handle this differently. And it depends on your comfort level with stuff, right? I mean, you could say I got 2 x's up top, and you know, x times x up top will be x squared. I can just cancel those. Some people might say, you know what, let's actually do this and get 30x squared over 25x squared. You know, that I can operate better if it looks like something I did yesterday, right? Because now it's in that form. And from this, we can say, well, that's let's get the restrictions. We're now in factored form, right? So the restriction is that x can't be 0. The common factor is what? 5x squared giving me a 6 here, and 5x squared giving me a 5 here. And so ultimately it's just 6 over 5, right? So that's one way to do it, perfectly valid. Okay, nothing wrong with that. I mean, all it's done is combine it and then just say, okay, now let's do yesterday's stuff. Okay. Other people may look at that and say, 15, 25, right? You can just do a cancellation in place, and I got x times x is x squared, and I'll just cross off all the x's. Okay. Just remember, state restrictions. Okay. So whatever you're comfortable with, right? And people coming from 20-1 we have a different level of comfort with this stuff, right? They've done this before, so. You do what works for you, as long as it's correct, right? Negative 3x squared over 10x cubed divided by 27x. That's it, divided by 27x. Okay, so that's the way it's sitting on paper, right? That's the way you're first going to see it. So I'm going to go in, I'm going to make a little modification to it. I'll do this in red so you can see the mod. And I'm just going to write that as over 1. Right? Just so that I now have a rational expression and another rational expression. Right? So basically anything can be turned into a rational expression simply by putting it over 1. Okay, what do we do with divide? We change it to multiply, right? I'm going to do one other thing. What's negative 3x quantity squared? Right? Because the squared isn't on there. It's saying square that. What is negative 3x all squared? Anyone? 9x squared, right? So 9x squared. It's positive. You're squaring a negative. When you square anything, you get a positive, right? So it's positive So really, if I see a negative inside something I'm squaring, I just say, okay, forget the negative. It's going to be positive, and then 3x times 3x is 9x squared. Over 10x cubed, we're going to change this into a multiply. So 1 over 27x. Okay? Non-permissible values or restrictions, right? Restriction. What's the restriction? So start here. It can't be 0. Go up top here, it can't be 0, or the bottom here really, right? So we're looking in 3 places, here, here, and here. The only restriction is that x can't be 0. Okay. What do you want to do to simplify this? Do you want to multiply it all together and then simplify after? Okay? So I don't mind doing that, right? It's not how I would do it, but how I do things doesn't necessarily have to be how you do things, right? I mean, what we want to do is find a way that works for you that gets you the answer. So if I show you a way and you know, look, can I just do this? I'm just going to say, do you get the right answer, like all the time? And if you say yes, then it's fine, yeah. Do it. I mean, I would just go 9. I cross off the 9 and the 27 and put a 3, and I take out the x squared and that. But, you know, that maybe doesn't make sense for you, right? Yep.
Can you show it your way too?
Sure. So let's just do this, and then I'll show you my way. Or the highway. No. All right. So now what do we want to do with this? I'm going to extend the page. Okay, we've already stated the restriction, right? Okay, so 9x squared will be the common factor, and I'm going to put a 9x squared down here. To get 270, I'm going to go 270 divided by 9, which is 30. And to get x to the 4th, I'm going to put an x squared, right? And now what am I going to do? So what goes up top, seeing as there's nothing there? It's a 1, right? Whenever we cancel, there's always a 1. So this is 1 over 30x squared. Okay? Good? Yeah? Okay. Now, so what would you do? This is what I would do. So here's the thing here, right? I would do this. I would say 9 goes into 27 3 times. I would say the x squared is going to take out 2 of these, leaving me with an x. And so up top I have a 1, and on the bottom I have 10 times 3 times x, which is 30x. Okay? So either one of those methods, whatever works for you, right? Both give you this. Oh, and there's an x here, so that's actually squared. They should work out the same. Okay? So either one of those, whatever works for you, right? And, you know, how do you know it works for you? You do a question, you check the answer. If you're getting the right answers, then that method's working for you. You know, is this that much longer than that? It's a little bit. The problem with doing this is sometimes you lose things, right? Because there's a lot of stuff crossed off, and what's the first answer I wrote? 1 over 30x, right? When did I know that was wrong? When I looked here. I said, oh, right. So sometimes you lose things by doing it this way. You're not going to lose anything here, right? Because you've made it specific and you've pulled your common factors. And okay. 24m over 36m squared times 3m over 5m cubed. Okay, it is a multiply. Everything's in factored form, and, well, not, yes and no, but there's nothing really to factor. And there's only one variable, so just m can't be 0, right? If m is 0, this gives you problems, that gives you problems. That's your restriction. Okay, so do we want to just multiply it out? Let's continue that way. So I can say, okay, this is 72m squared. And this is, you got calculators, right? 180, 180 m to the 5th. Okay, see, when I learned this stuff, we didn't have calculators. So we didn't want to do this kind of multiply, right? It would be inefficient because you'd have to sit down, piece of paper, multiply it out or something. You got calculators now, so it's no big deal. Okay, what goes in, what do we think our largest common factor? And, you know, we might not find it right off the bat. Okay, so let's say 9. Okay, so 9m squared, right? Because our lowest power of m. And what's that going to give us here then? What goes in here? 8. Okay, and 9m squared, and what goes in here? 20 m cubed, right? Okay. Now, remember step 4 from yesterday, which was check. Can this be reduced? Yeah, because we got an 8 and a 20, right? What goes into 8 and 20? How about 4? Okay? So 36 was really the biggest common factor. All right? And it's fine. So what? We didn't see it right off. Who cares? Doesn't matter, right? Just then we did one extra step. Right, now you're going to say, well, how would you do it? This is what I would do. 3 goes into 36 12 times. 12 goes into 24 twice. I've got 2 m's up top, which will take out the m squared on the bottom. So I get 2 times 1, and let's try and do this correctly this time. So I get 1 over 5m cubed. Oh, 2 times 1, which is usually 2. So I get 2 over, so see, obviously my method doesn't work so hot because I've gotten it wrong twice in a row now. Okay? So here, we would have saved one little thing if we'd have recognized 36, and you couldn't, how do I know 36 is a factor of this? Well, because it's 36 times, right, and we should know 36 goes into 72, right? So, yeah. That could have saved a bit of time, but you know what, time is not your enemy on most of the stuff that you're doing, right? You can make it your enemy by wasting a lot of time on something that you shouldn't be spending the time on a test. So, but that's test writing strategy, right? You just got to work on your test taking skills. Uh, 5p to the 4th over 9p. Okay, what's the first step in dividing? Okay, first step is factor. Is there anything to factor? No. Right, they're all just single terms. Okay, then, what do we do when we divide? Kiss and flip. Okay? It's an 8. So no matter how you do this, right, whether we're doing it the way that we've been doing it or my way, this is the first step. You have to do this first, okay? What you do after this is up to you, but you have to do this first. Now we need to state non-permissible values. We got to look in 3 places. Here and here because they are denominators, and here because now it is a denominator. So what are the non-permissible, so what are the restrictions? What can't A be? 0. What can't P be? Also 0, right? We have 2 restrictions. We have 2 variables, A and P, neither of which are allowed to be 0. Okay, what do we want to do? So let's just do it. Negative 36p cubed over 30a p to the 4th. Okay, so we're multiplying, this is like multiplying fractions, right? You multiply the numerators together, you multiply the denominators together. Looking for a common factor, well, we know 6 will go into 36, right? So let's go with 6p cubed. 6p cubed. So how will I get negative 36p cubed? What goes in here? Negative 6. I mean negative 6, right? Because we need to have that negative. Why didn't I take the negative out here? Because there's no negative on the bottom. Right? So it won't simplify out. Okay, we know that 6p cubed is our common. We need an a. Oh wait, we need a number first. What number is going to give me 30? 5. We need an a, and what else? And a p. And we get negative 6 over 5ap. Okay, questions? Nope. Moving on. Simplify. We're going to do binomial numerators and denominators, and we will do a bunch of these, right, because they're more complicated. So, you know, they are and they aren't actually. It's kind of interesting. The monomials might be more complicated because we're taking stuff and having to multiply it together. We're going to do slightly different with here. So simplify. Again, that's the basic instruction, right? Simplify. And we're going to use binomial numerators and denominators. So this isn't part of the instruction. It's just telling you that that's what these examples are, right? Binomial numerator and denominator. Okay, here's the first one. Okay, remember restrictions, right? Restrictions. Always, right? That's an always. Always restrictions. Okay, A. Actually, this is like 3, isn't it? Because we only did 2. 3. 2x. 3x minus 1. Okay, so it's a multiply. It's in factored form already, right? Everything's been factored. So step 1 is factor all the numerators, factor all the denominators. There's nothing to factor here. Okay, so step 2, non-permissible values. So let's just start here. Can't be 0. Can't be. Can't be. Okay, so negative 6 and 0, 0 and negative 6. I don't really care what order you state them in, just get them all. Don't get too many, right? It can be 1/3, right? Even if this were division, we wouldn't be checking here, right? We'd be going here, here, and here. Okay, but it's not a division, it's multiply. Okay, so what are we going to do? Well, what we're going to do is we're going to put this together. I'm going to go 2x times 14. I'm going to get 28x. I am not going to multiply the factored forms together, right? That's the last thing I want to do because I want to see if these guys will cancel. On the bottom, we're going to get 56 x to the 4th and an x plus 6. Okay, so we're going to multiply the monomials together into a single term. Then we'll go back and we'll cancel later. And anything that's already factored, any binomial, right, just stays. You're never going to expand those out. We're not going to FOIL them. So can I cancel anything right now? What can I cancel? X plus 6 and 6 plus x, right? They're not exactly the same, but they are, because this could just be written as x plus 6. Okay? So those are gone. Now, does anything else cancel? Well, we know, yeah, these guys are going to simplify down, so let's just give it another line. So 28x will be the common. And we'll take a 28x out of the 56x to the 4th, leaving me with. So 28 times what gives you 56? 2. And x times what gives you x to the 4th? X cubed. And now these guys cancel, and we get a single. So the idea is we need to end up with a single rational expression, right? So in other words, it's something over something. There's no times now. There's no, right? It's all being combined. Okay, any questions? Yeah?
How'd you get the 2x cubed at the bottom?
Okay, so the bottom is 56x to the fourth. See the 56x to the fourth? Okay, now top has a 28x. The common thing between the 28x and the 56x to the fourth is 28x. So I want to factor a 28x out of 56x to the fourth. Okay, and when I do, I'm left with the 2x cubed. Okay. Now, I mean, at this point, some people might just do this, right? Whoops, I won't do that. They might just say, okay, so now I've got the 3x minus 1 and I've got the 2x cubed. So that's perfectly valid as well, right? You just say, hey, I can cancel those monomials where they're sitting there, right? I don't need to rewrite it like this. But if you want to, rewrite it like this, right? Then it makes it, yeah, this is obvious these cancel, right? They're the same. What's next? 8 times 4t plus 1. Oh, sorry, this is actually divided by. Sure. Divided by. Okay. Be looking at this and saying, hey, I think some things are going to cancel. Oh, I'm going to have to pull that little trick because this is 4t minus 3 and this is 3 minus 4t. So remember that factoring a negative out because we can make those the same. But it's division. So first off, we should factor. Is there anything to factor? No, they're all factored, right? There's nothing that can be simplified. Okay, so then the next step is rewrite it as a multiply, right? Okay, now you know I'm going to do something with these guys. If it's a binomial, I'm going to throw it in brackets, right? Just to separate out, just so it's obvious to me that's a binomial, right? Oh, should be an equal sign here, right? Because that is equal. So now what we can do is put the top, oh wait, we got to do restrictions first, right? Sorry. Okay. From the factor form, now we do restrictions. Restrictions, remember, we're looking in 3 places, here, here, and here. Or we're going here and here, right? I'm doing these denominators, and then I'm doing this denominator. Okay, so what's the restriction here? 3/4. What's restriction here? It's kind of a little backwards, but really it's the same as this, right? It's 3/4 again, right? Because if you put 3/4 in here, you'll end up with 3 minus 3, which will give you the 0. What's restriction here? I hate it when it's backwards, right? Are these two terms the same? 4t plus 1, 1 plus 4t? Yeah, they are, right? Okay, so what would the restriction be here? Make this negative, divide by 4. So it's just negative 1/4. Okay, so 2 restrictions. Well, okay, let's write this. Actually, I'm going to, I'd like to, if I can, I'd like to, no, can't do that. No, can't do that. Apparently can't do that. I just like to put the 4 out front, right? So it doesn't sort of get stacked in the middle there. Okay, so actually when I write this, I should say, all right, let's take the number 4. Okay. Now I know where this ends, and I can get there pretty quick. Let's try this. We know we know these two guys are the same, right? Okay, so what do we know about these two guys? So that's a really weirdly written 3. What about these two guys? If I take a negative out of 1, they'll be the same, right? Okay? Let's do this. What if I put a negative here and then cross these two off? Right? Okay, so what am I left with? Negative 8 over 4, right? Which is negative 2. Okay, so we're canceling these two guys because they're identical. We're saying that's that trick, right? Or if I put a negative, so I'm going to put a negative down. That now flipped this. I'm not even going to write that it's flipped, right? I'm just going to now cancel it. Okay, is that okay? Is that too much? All right, because as you do this, you might develop your own company. Hey, I can just do that. Like, I don't need to combine these monomials and that. But reach your comfort level. All right, a few more because I read the thing and it said lots of examples. 2a squared plus we need to actually do a few more that have, we want to see all the different kinds of stuff, right? This time we're actually going to have to do some factoring. So 2a squared minus 8a over 6a plus 12 times a squared minus 4, right? What do we know about that? Okay, step 1, factor. This time there's a lot of factoring, right? As a matter of fact, everything factors. So we have to do 4 factorizations. Okay, so factor this. Is this a difference of squares? No, that's not a square, right? If we factor the a out, will it become 1? I don't know, I don't think so. Okay, but what's the common factor? So first step in factoring is always to common factor. So, but to what? 2a, right? Because typically we're Canadian, so we say 2a. And what's left? A minus 4. Okay, let's go down bottom. 6. And what do we got? A plus 2. So remember, you only have to factor binomials, right? You guys come down 20-1 are going, really? Just binomials? Except, so the hardest thing we're going to have to factor is a difference of squares, so how does that factor? A plus 2, a minus 2, a minus 2, a plus 2. I usually do the plus first and the minus later, but only because sometimes there's 4th powers, which leads you to another difference of squares, which factors again, and blah, blah. And what do we get on the bottom here? 5. Okay, now we state restrictions, right? It's just a multiply, so we're only looking here and here. So what are the restrictions? 4 and negative 2. Okay? As far as good? Usually I would do it from here, but let's put it all together, okay? So, 2a, a minus 4, damn, ran out of ink. A minus 4. On the bottom, we got 30. Now, if you wanted to, you could have done the 2 with the 6, right? But I'm not going to. We're just going to say 30. A plus 2. A minus 4. Shift this a bit. Okay, what are you going to cross off? A minus 4, right? A minus 4, 1. A minus 4, 1. What else? A plus 2, 1. Plus 2, 1. You okay if I do this? 2 goes into 30 15 times? Sure. Are you guys okay with that, or do you want to? Okay. I mean, the other way all we would do is then just write this as 2 times 15 and then cross off the 2's, right? Okay, what do we got? We got an A and an A minus 2. And on the bottom, we got a 15. No, this is 30 dash. Yeah. Okay. So we good? And remember the restrictions, right? Which we wrote somewhere up there, right? Which can't be what? -2 and 4. Okay. Because you always want the restrictions to relate back to, your simplified form. Okay. And what are we saying? Really, what we're saying is, any value of A you stick in here, you will get the same number if you stick that same value of A in there. Right? It's the simplified form. They should evaluate to the same thing. Right, next. Don't worry, only a couple more. D. You got all weekend then. Okay, so this time it's a divide. What's the first step in doing division? No. So first step is kiss and flip, right? Then we'll go into factor. You could factor first and then do the kiss and flip. I'd rather just rewrite it as a multiply. So that's equal to 10x cubed over 6x cubed minus 10x squared times 12x minus 20 over x to the 4th. Okay, and now all we're doing is what we've been doing all along, right? This is now just a multiply. Now we're going to factor everything that can be factored. Restrictions after factoring. Because it's harder, I mean, it's kind of obvious here x can't be 0, but it's harder if something like the 12x minus 20 to figure out what the restriction is. So a factored form makes it easier. Okay, what are we going to take out? 2x squared? Giving me 3x minus 5 times, I'll bet you this factors to a 3x minus 5, whatever else goes with it, which is a 4. How did I know, right? I mean, this had to cancel with this, right? And so the factored form of this had to include a 3x minus 5. It just makes things simpler. But you check it out, right? It's 12x minus 20. And then we got x to the 4th. Okay, so step 1, rewrite it as a multiply. Step 2, factor everything that can be factored. Step 3, state the non-permissive or the restrictions. Okay, so let's start here. 0, 5/3, right? This, change sign on this, divide by 3. 5/3, and 0. Okay, remember, we're checking 3, right? This, this, and this. These two because they are denominators, and this one because it was a denominator back in the original division statement. Okay, let's combine. I got 40x cubed, 3x minus 5. I've got 2x to the 6th, 3x minus 5. Okay, so I combine my monomials, right? I will never combine the binomials in the sense if there are two, I'll never FOIL them out, right? I always want a factored form of them. Okay, what do we do? What do we do first? Cancel 3x minus 5, right? These are the same. So that leaves me with okay, so what's this going to end up as? 2 over x cubed, right? Okay. Do you see that? You want me to show you a little?
How's it 2? 20.
Right. 20 over x cubed. Maybe I do need to do. So it's 2x cubed times 20 over 2x cubed times x cubed, right? So those are my common factors that cancel. And we get 20 over x cubed. Okay. Questions? Am I going too fast? Or we leave that up there for a second? Good? Sorry. All it takes one person to say, yeah, I'm good. Go. Okay, 2 more. E. Okay, first step. Factor. You see two terms with a minus sign in between them and a square. You have to think, is this a difference of squares? So, is 4x squared minus 9 a difference of squares? Does 4x squared have a square root? Yeah, what is it? 2x. Does 9 have a square root? 3. Okay. So this is 2x plus 3, 2x minus 3, 4 and x plus 12. Two x squared minus 18. Is that a difference of squares? It is, but you got to do one step first, which is what? You need to factor out the 2. Okay, so here we'll write, so 2. Now, how does x squared minus 9 factor? X plus 3, x minus 3. Okay? And on the bottom we've got 2x minus 3. So if I have binomials, I like to throw a set of parentheses around them, right? Put brackets around them. Just bracket them all. Now, we can write this all together, or we can just go in and start hacking and slashing. What do you want to do? Just hack and slash? Okay. 2x minus, oh, restrictions. Good, see? That's why I didn't do it. I wanted to see if somebody would say it. Okay, it's a multiply, right? So we're just looking here and here. So what are they? Okay, negative 3, 3 over 2. Good, just checking, make sure you get a restriction. Okay, what am I going to cancel? You may cancel any top with any bottom, right? Doesn't matter, forget the time sign. Really, you could just do this, right? You could just say, yeah, it's that. Okay, what would you like to cancel? Say something. Anything. Okay, what else? What else? One more thing. The 2 and the 4, right? Okay, so what have I got? Up top, I have 2x plus 3, so let's not forget these. I got a 2x plus 3, I got a 1, I got a 1, I got a 1, and I've got an x minus 3. On the bottom, I've got a 2. The 4 was what became the 2. I got a 1, and I got a 1, and that's it. Okay, so we're done. Questions? Concerns? Comments? One last thing. I'll give you a second. If you don't get a copy down, these will be up as a PDF on the website shortly. And this whole thing will be up shortly as well. Here's one. This will be number 4. Bless you. Right. 2 rational expressions whose quotient right? 2 rational expressions whose quotient is negative 6x over 5. So, what's a quotient? What's a quotient the result of doing? Adding, subtracting, multiplying, dividing? Dividing, right? So what we want to do is we want to take something divided by something equals negative 6x over 5, right? That's what we're looking to do. Now, obviously there are infinitely many of these things, right? So really what we need to do is we need to write, you know, something divided by some other thing and there's a restriction that x is not equal to 0. Okay? Now, usually in math, we don't use something and some other thing. So we need to write an expression of this form. A over b divided by c over d is equal to negative 6x over 5, where x is not equal to 0. So, what do you want to do? I mean, we just really plunk anything down, right? As long as it divides out to that. I don't like dividing, so what do I do instead of dividing? I multiply. So let's change this into a multiply. So I need b times c to end up as a 5, right? But they should be rational expressions. Things should cancel out, and basically it should end up simplifying down, right? So, I don't know. Obviously we're going to need a negative 6, okay? So I need negative 6. It's going to end up sticking around. We need a 5 that's going to stick around as well. So let's throw in here. Let's throw this in. Okay. So see that? What I've written so far is going to simplify down to negative 6 over 5, right? Because the way I've written it, I'm going to cancel the x plus 2's on the top and the bottom. What else do I need? An x up top, right? Now I like brackets around mine. Okay, where'd you get those? I pulled them out of the air, really, right? I mean, it's made up. They're just an expression. So I just started out by saying, hey, I need a negative 6. So I'm going to put a negative 6 down. It's going to be a rational expression, so let's multiply it by x plus 2. I need a 5 on the bottom. Let's put a 5 down on the bottom. Okay?
Did you just make that up?
Yeah, I just made that up. Pulled it out of the air. The slight problem, though, says that x isn't supposed to be equal to 0, and I've got x not being 3 or negative 2. I don't know how strict they want to be on that. I like this. We'll go with this. Let's extend the page. So this would be negative 6x minus 12 times but it was supposed to be a quotient, right? So now I got to flip this. Okay, there you go. That is a rational expression whose quotient will equal negative 6 over 5. Right? How are you going to figure that? Well, yeah. All we got to do is take it backwards, right? Let's work our way up the page. If I gave you this as the problem, right? Then the first step you would do is to rewrite it as a multiply. Then the second step you would do is to go in and factor everything. Then the third step that you would do is to simplify. And you will end up with that negative, right? Because simplifying now, gone, gone, negative 6x over 5. All right, so, you know, there are, you know, I could have done anything. There are infinitely many answers for that. Okay, and you could follow the same thing.